Hello everyone, this is Kunal.
My name is Somesh.
And today we are gonna present our group project on real-time batch processing and stream processing using Kafka, Nginx servers, and MongoDB. So the primary project goal of this project was to build a scalable pipeline capable of both real-time and batch processing of access logs from cluster of web servers. The pipeline which we created tracks the report of most visited pages uh, in real time, that's every 1 minute, and provides daily summary of access data. This project aims to demonstrate our ability to handle large amount of data, processing efficiently and effectively. So for this, we created a server app which will have 4 to 5 product pages, and when we try to request these pages using our HTTP request, the logs will be created on our web servers, which are Nginx web servers, and these logs will be transferred to MongoDB through Kafka. So what we use a Docker to deploy all our components into separate containers, and for the same we use Bitnami Zookeeper for deploying Zookeeper, and Bitnami Zookeeper is one of the pre-built image for Docker. Next, we use Bitnami Kafka for deploying the image for Kafka, and we use two of the clusters. So you can see Kafka 1 and Kafka 2 up and running. Next, we use Nginx servers, and the image which we use for this was Nginx Stable Alpine, which is also one of the pre-built image for Nginx, and we actually created 3 web servers, but as of now we are using only 2 of them. Next, we also created a load balancer which will balance out the load from web server 1 to web server 2, and we use Nginx Stable Alpine, same image as above, and the port for this is localhost 8080. Next, we use the Mongo latest, which is one of the image for Docker for deploying Mongo. So next we'll be seeing the demonstration of the project, and it will be carried forward by Somesh.
So as you said, like we have created different APIs that we are going to send requests. So we'll start by sending requests. So I'm using the Thunder client to send requests to the
First, you need to
different product pages. For that, we need to up the container. So we are going to run the compose up in background. That will start all the containers. As you can see, all the containers have been started. From the Docker desktop, you can see that MongoDB server, Zookeeper, Kafka 1 and Kafka 2 are the two clusters. Logs app, this is the app where the logs are being produced using the producer, and these are the two Nginx servers, and this is the load balancer, which balances the load. So what we are going to do, we are going to send the request to different product APIs. For example, product 4, we are going to send the request product 4 successfully fetched. Product 3, you can see product 3, product 1, product 1. So what is this doing? This is sending the request, and the Nginx servers load balancer is balancing the load and giving the load between the two servers. So, and from there, a log producer will produce the log that is that we get from the Nginx server to web logs topic. You can see it here, and this web logs topic will be then consumed by log consumer, and the data will be saved to the database, that is MongoDB. So for example, as we send the request, we can see I've also made logs API that will directly show us the data from the database. You can see that the product 4 was accessed uh, as we sent the request. It was accessed by the server IP, that is 1908, and as we go down, We can also see one more server IP. You can see it here. The server IP is 0.1907. That is, we have two nginx server. That's why we got two server IPs. If we had three, the load balancing will be there between the three servers. And these were the logs saved directly into the database. We can see that in directly in the MongoDB database also. This is the test. We have entered the database. You can say show collections. Wrong spelling. You can see the logs and the most visited pages as the two collections. We can further type db logs dot find. We can see the logs are saved into the database. As we have requested, the logs have been saved. If we request it again, one more log will be saved. For example, product 1. For example, product 1, we sent one log, it successfully fetched. We can again say, and you can see the product 1 has been logged. And you can also see the timestamp that is the same as we logged at right now. So these are the logs saved directly. Now we want to create the stream that measures that consumes the same topic and creates the n most visited pages in p time. For that we have used Kafka streams, but as we are using the Node.js environment, Kafka stream only works for the Java and Scalar. So we have hand coded the aggregation method, and we have created the producer and a window function that will last for 1 minute or any p time as you want. For now, I have kept it to 60 seconds, that is 60,000 milliseconds. And this log will then again produce to the topic called most visited pages, and it will be consumed by the third consumer and will be written in the database. You can also see that's why the second collection was there. Show collection most visited pages. So for this, you can see db dot most visited pages dot find. These are the most visited pages between for the last 1 minute. You can see uh, a product 1 was only accessed one time, that's why it's one time. Product 1 was accessed 6 times, that's 6 times. Product 3 was accessed 8 times. This is for last 1 minute, like 1 minute log. You can also directly see that in the Thunder client and visited page count. You can see it here also. And same results are logged in the log app that we are producing. You can see it here. The product 1 is count 6, product 3 count 8, product 4 count 9. This is the log that we were fetching. Means these are the requests that we were sending through Thunder client. For example, I'll just show you it again. We are sending the request. The product 5, you can see product 5 has the log has been saved successfully again. And you can also see the load balancing. The 19.0.7 is the server, the two web servers we can see. That's how load balancing is happening. Same with this. After exactly 1 minute, we will get an aggregated result. Also, this activity that we are manually doing can be done using a JMeter. directly. We should get the aggregated result now, I guess. Yeah, just few seconds more. Access more pages to them. Yeah, we got the aggregated results. Product 5 was counted 18 times, 4 was 35, and 1 was 49. These are the aggregated results, and same will be saved in the database. So that was the project demonstration by us by say we are saving the logs and the results table in the database. And we tried doing the batch processing, but due to some time constraints and the we as we have used the Node.js,
We
the
weren't able to
we
configure
weren't able to configure the
batch
batch
processing.
processing, but we can try and we will do
Carry
few.
forward this later.
Yes. So that's from
That's
our
all from our
side.
side. Thank you.
Thank you. Carrot. Bye.